Okay, so homework 11, can you write on there that it's due Thursday? So homework 11 is due on Thursday. We're going to spend today and tomorrow talking about limits. Just like chapter 2, chapter 4 has 2 assessments. The first one is a quiz, and that's on October 4th. That's a Wednesday. And then our test is scheduled for after fall break, because we're going to have fall break in between there, on Friday, October 20th. Okay? So I'm going to actually do this a little backwards a little bit. I want us to jump right into the graph. And somewhere along on the notes, you can go ahead and put the homework and practice to the side. Near the bottom, I want you to copy down this notation, what this notation means. Because this is a new notation. When you see a minus sign after the number, that minus sign that comes after means from the left. A plus sign after the number means from the right. And then if it doesn't have a plus or a minus, that means it's at that point, and the left and right must be the same. So I'm going to give you a minute to kind of copy that somewhere along the side, and then we will talk about it. So we're in our notes packet, and then we'll do one of the practice questions. And so for today and tomorrow, we're simply just looking at graphs. Looking at a graph and finding the limit. Looking at a graph, finding the limit. Okay, if at that point, if it's not the same, the limit does not exist. So we talked about in chapter 2, there's 3 different types of discontinuities: a jump, an infinite, and a removable. If you see a jump, if there's a jump, well, I'm not even going to, I'll write it. It's D and E. Removables have a limit, though. A removable or a hole has a limit. Does not exist right here. D and E does not exist. Some people write NA, but the technical term would be does not exist, D and E. Now, infinites can vary, but I'm just going to say that all removables have a limit and all jumps don't. And we'll talk about infinites when we get there. So what I'm really going to focus on today is reading the notation, because we have this graph that has some discontinuities in it, and we're going to learn how to read what this notation is asking us. Now, keep in mind, when it says limit, this LIM means limit, and this is always referring to the graph. What is the graph doing? Okay, so we actually had this on the quiz. This is saying, what is y when x is 2? I should probably also mention that the graph, this is kind of counting weird. It's counting by a half. So this is 1, and this is 3 if you want to number it, because it is kind of it's scaled in a weird way. All right, so when we look at x equals 2, this is x equals 2. Which one of these points do you think I'm going to look at for the value of y when x is 2? The open or the closed? Which one? The closed. Okay, so what is the y value equal right here? So the answer to A would just be 3. So now let's look at part B. This means from the left. From left. See how you have that little minus sign that comes after? That means from the left. So if I draw a wall at 2, the left side of the wall hits right here. That's where the graph is hitting the wall on the left. What is the y value of that red dot? 1. So that would be your limit. The limit is 1 from the left. From the right, on the right side, we have a point here. What is the y value of that point? Of the blue dot? 3. I'm sorry, yes. Trey.
How do you know which dot you're starting with?
All right, so you're looking exactly on the green wall. On the green wall. So which is at 2, on the 2. And I'm saying on the left side of the wall. So you see how the graph on the left hits the wall at 1? And on the right side is hitting the wall at 3. That's your limit. Thank you. Okay. So when you look at questions D, E, and F, now question D is asking you, first of all, when we look at B and C, are these the same? Are they doing the same thing on the left and on the right? There's 3 handouts in the front. Are we doing the same thing on the left and the right? Hello? Anybody here? Hello? Yes or no? All right, so that means that right here, what kind of discontinuity do we have right here? What do we call that discontinuity? It's a jump. And because the reason why jumps don't have a limit is because the left limit and the right limit don't match. In order for you to have a limit at a particular point, the left limit and the right limit have to match. And that's why the answer to D is does not exist. And that's all we're going to do. We're going to just keep looking at graphs. It's going to be a little icy in the beginning. But by the time we get through with our 40-minute class, the smoke will start to clear. And then by tomorrow, we'll be in there. All right, so now let's look at a different point. Let's look at positive 3. So positive 3 is right here. So at the 3, which one of these y values am I going to look at? 2. So that would be your answer to part E. Now I'm going to draw a wall. Question F is asking, where does that graph hit the wall on the left? On the left would be right here. And on the right is right here. So on the left side of the wall, the limit is, on the left side of the wall, the limit is 3. This is the left side and this is the right side. Like this is right, this is left. Left, right. So you're looking directly at the graph and you're looking. So I'm putting the dots there because, so this is the graph on the left. It hits right here. This is the graph on the right. It hits right here. So let's look at on the right. On the right, So if I were to draw it on the right, this is the graph on the right. Would you agree that this graph is on the right? Where does it hit the wall though? At 2. So your limit is 2.
Does it matter if it's open or closed circle? You're just looking for the limit.
Where does it hit the wall?
It doesn't hit the wall on the x-axis. On the y.
We're looking for the y value. All right, let's look at h. I'm going to keep kind of going through it because I think the more you're exposed to it, it'll kind of click. So let's look at h. So here, for x equals 4, that's right here. This is x equals 4. Do you see a discontinuity right here? No. So that means we have a limit. What is the y value where my laser is? What's the y value of this point? 3. So that's the answer to h. But it's also the answer to I. I is 3 and h is 3. And the reason why h equals 3 is, again, if I were to draw a line right here, do you agree? Let me zoom in really close. Do you agree that the graph on the left and the right, they're coming together at the same spot? So that's why we have a limit. The left side is approaching the same spot as the right side. They agree. It's an agreement. So we have a limit. All right, let's look at example 3. Let's look at a different graph. So first of all, we have as x approaches 4. So let's look at 4. And I want you to tell me, do we have a discontinuity at 4? That's your first step. So I'm going to look at 4. So 4 is right here. So right here, if I go directly up to the 4, at this point, is there a discontinuity right here? No. So that means we have a limit. And the limit is whatever the y value is at this point. And what is my y value? 2. So that would be your answer to 1. For question number 2, this means from the left. From left. Number 3 says from the right. All right, so if I let me draw a line. First of all, before I even look at that, do we have a discontinuity? Is it continuous at 3?
Yes.
It is? So if I'm tracing along the graph when I get to 3, this part is connected to that point. If this does not connect to here, it's not continuous. So this is not continuous. So if you draw, if I were to look at it, and if I were to draw a line, this little blue wall here, what is the graph doing on the left? So the left side, this is the left side of the wall, is going down. Would you agree?
Yeah.
Right at that blue wall on the left is going down. So what's the limit on the left? Negative infinity, because it's going down. But on the right side of the wall, which is right here, it's constant. It's just hitting the wall right here. So the limit would be 2. In order for you to have a limit for 4, 2 and 3 have to match. Are these two numbers the same? Do we write the same thing for the left and the right? No. So that means for question 4, it does not exist. This does not exist. The left and the right have to match. All right, let's look at 5, 6, 7, and 8. So let's look at 5. So now we're going to look at 0. Do we have a discontinuity at 0? We do. It's an infinite discontinuity. So if I draw me a little, and again, you don't have to draw these walls. This might be confusing, I don't know. But if I draw a wall right here, on the left side of the wall, which is this arrow, is going down. So that means the limit on the left would be what? Negative infinity. On the right side of the wall, which is right here, is going up. So the limit would be a positive infinity. Now, are they the same? Is the left and the right doing the same thing?
No.
So that means for number 7, I'm going to say does not exist. If you had an infinite that both went up, then you could say it's positive infinity. If both sides went down, you could say negative infinity. But I will take does not exist because that's actually something that's like debatable in the math community. Some professors say that if they both go up, the limit is positive infinity. Some professors say even if they both go up, they're not connected, so it does not exist. I'm not going to get that technical. All right, what is this? What this is asking you here, when it says what's the limit as x approaches positive infinity, that's saying the far right arrow. Far right arrow. What is it doing? On the far right.
Going down.
So this is the far right that I have circled right here. Would you agree that's the arrow furthest to the right? Because there's a lot of arrows happening here. But what's happening on the furthest to the right? Is it going straight? Is it going up? Or is it going down?
Straight.
And what is y equal? 4. So that would be your limit for positive infinity. So the far right, or maybe you should say the furthest right arrow. Even though we have a right arrow right here, we're not looking at that, and we have a lot of arrows happening here. But we're looking at the arrow far to the right. This one is saying farthest to the left. So the arrow that is furthest to the left would be this one that I have circled in green. And it can either do one of 3 things. It can go up, down, or straight. What is the left arrow doing? Furthest to the left. So your limit would be what? Positive infinity. All right, -2. What kind of discontinuity do we have here? That's a hole. Holes are the only one that have a limit. So let me zoom in. Even though we have a hole happening at -2, do you agree that the left side and the right side are meeting up at the same place on the wall? The place that it meets up is right here. And what does y equal for this open circle? That would be your limit. Removables are the only one that always have a limit. So the answer for 10 would be 3. Okay, +5 is right here. That's a jump.
What if that was a removable jump?
A removable jump to combine. We can't have that. It's either one or the other. All right, so number 11 at x equals 5. That's a jump. Jumps don't have a limit. So that is D and E. The reason why they don't have a limit is because the left and the right are doing different things. The left side is approaching 2 and the right side approaches 4. So for 11, it would be D and E. For -5, that would be right here. Right here at -5, we don't have a discontinuity. So my limit would be whatever the y value is right here, which appears to be at about negative 1/2, negative 0.5. I'm approximating that. All right, so let's go ahead and name these three limits real quick. For number 13, at x equals 0, what kind of discontinuity do you have at x equals 0? Infinite. At x equals -2, removable. So this is -2. This is your 0. And then lastly, at x equals +5, right here, what is that? That's a jump. All right, I think we're looking at another graph. Yep, let's look at another graph. We're just looking at all kinds of graphs. I want you to try to do A, B, and C by yourself. Take a guess for A, B, and C. All right, so 3A, I'm just going to say this means from the left. And then B is saying from right. Wait, let me go ahead and back up a little bit because I can't get it to fit. Okay, so this is saying from left. And this one is saying from right. And then as long as A and B agree, then C has a limit. If they don't agree, it does not exist. So I'm going to draw in a vertical line at 3. On the left side of the wall, the graph is hitting right here on the left. And the graph is hitting right here from the right. So you should have 1, 0, does not exist. Who had that? 1, 0, D and E. Now when we look at question 4, we have to determine, is it 1 or is it 0? Which one is closed? When we zoom in here, the 1 is closed, so the answer would be 1 for question D. All right, I want you to do E and F. Okay, E is a trick question, but I want you all to try to do it anyway. We'll talk about why E is a trick question. Because remember, limit is left and right. Okay. So 4 is actually D and E. Does anyone know why 4 is D and E? And that's a trick question if you didn't get that. Joshua. Right. In order for you to have a limit, if I draw a line here at 4, do you all see that nothing is happening on the right? So we don't have a limit at 4. We have a limit coming from the left, but we don't have a limit at 4. So that's why that's D and E. And the answer for F is the closed point at 4, and that would be 1.
So what would, for E, what would it have been if it was a +4? Because there's nothing that goes.
D and E. There's nothing there.
So it has to have stuff on both sides.
Okay, and then 1 at 1. What kind of discontinuity do we have there? It's a removable, and removables have a limit. Even though this is an open circle, the limit is 5. Removables always have a limit. So the answer would be 5. Okay, so now we're going to talk about in behavior, and then we're going to do one of the practice questions. So I'm going to give you a minute to copy down this template. We'll just do one at a time. So go ahead and copy down these. We're going to write this statement over and over again. So I'll give you a minute to copy down these statements underneath each graph, and then we'll fill it in.
No, we don't do shit with this, Brian. You don't. And I love that. Okay, I wish you had a 7. It's so like relaxing. I can't think of anything. You wouldn't go to this thing? Oh, today? Why? Did you miss the first one?
No, I'm about to pick this because. What is X equals 4? What's number 24?
What else crazy? I think I'm gonna test the Allison section. What was that? Oh, Allison did the section.
Okay, so it's a lot of writing, but really you're just filling in what is the left and the right arrow doing. So what's happening on this graph, the negative infinity means from the left. So this means from the left. What is this arrow doing on the left? Going down, so your limit would be negative infinity. But on the right, what is it doing? So the limit would be, yep, you're just filling it in. That's why the longest part is to just copy down the statement. For the second one, on the left side, it goes up, and on the right side, it goes down. So that means that we would say, we would have positive infinity and negative infinity. Now, whenever it's an even function and the left and right side do the same thing, you don't have to separate them into two statements. We can say as x approaches positive and negative, which means on left and right, they're doing the same thing, they're going up. And on this one, on left and right, they're both going down. All right, so let's put our note packet away. I want you to do practice 1 by yourself, and then you're going to grade yourself. So there's 4 graphs. We'll come back to the notes tomorrow. I want you to do this graph by yourself, but I'm also going to add to it a part F that says, what is f of negative 1? So there's 6 questions. I want you to take, limit shouldn't take more than 30 seconds each. No. That's why it's practice. So we're going to do practice 1 today, and then tomorrow we'll do some more. So I want you to take a guess, answer all 6 of those questions, and then you're going to grade yourself. I'm going to put up the answers, and you can grade how you did. After day 1 of limits. Yeah. Pencils down when you're done. I just want to, because I want you all to take a guess for all 6 questions. And make sure you add F. Add F to it. I added a question right here.
Like add that question, not like add F in front of your answer.
Like,
No, it's actually where it touches that line. All right, who has 6 answers? Who needs a few more minutes? All right, I can give you another minute. Really, I can only give you 30 seconds because we only have 5 minutes left. Okay. I'm gonna put up the answers and you grade how many you got right. And then put a number off to the side. So you should have 2, 2, 2, D and E, and 1 out of 6. And I'm getting ready to go over it. How many got all 6 right? How many got at least 5 right? At least 4 right? Okay, we'll stop there. Let's talk about it. All right, so let's talk about it real quick. We only got 4 minutes. I need you all to lock in. So at the -1, which will be right here. This is -1. The graph is approaching +2 from the left side and from the right side. Both sides, the graph is approaching 2. So that's why my limit is 2 for A and B. And because the left and right graph both approach 2, we also have a limit of 2 at C. Remember, removables, if you see a removable, it's going to have a limit. Now, for F is saying what is Y when X is -1. That's when I look at this dot. That's why the answer to F is 1. For is it -4 next? At -4, we have a jump. Jumps don't have a limit. These two have jumps. They don't have a limit. All right, put these to the side. We're going to practice more tomorrow. We're going to keep looking at graphs. We're going to keep practicing, keep looking at graphs, keep practicing.